So let me quickly introduce myself. So I'm the Outreach and Training Coordinator of FAIRmat. And let's get started with the slides for those of you who are new here, FAIRmat is the NFDI consortium to build a federated data infrastructure for the field of solid-state physics and related fields such as material science. We operate under the umbrella of the National Forschungsdateninfrastruktur of Germany, which have several other consortia for the different fields. In FAIRmat, we operate into 7 functional areas, 3 of which are the key topical areas: synthesis, experiment, computation, and this basically covers the possible file formats and file types that are generated in our field. We have the infrastructure area, which basically develops the tools and the solutions we offer and make sure that we have the resources to run them. Use cases area basically uses all the developments from the other area to create demonstrations for domain-specific applications. The outreach and training area, and of course, coordination and scientific administration, which basically defines the direction of the project and steers its objective. In FAIRmat, we basically operate under the belief that the FAIR principles will change the way that we run our research. And very quickly, I think you all know it, FAIR is an acronym for Findable, Accessible, Interoperable, and Reusable Data. And in FAIRmat, sometimes we like to shift this acronym a bit towards findable, accessible, and findable and AI ready, so that the data is machine readable, and that's basically what we aim for in the preparation of our infrastructure. We also advocate the open science movement in the form of publishing our results in open access journals, and also all of our codes and services are open source, which means they're available on our GitHub and GitLab pages where people can fork and clone them, customize them, and so on. And most importantly is that we operate based on the needs of our community. So we're a bottom-up project. We assess what our community needs by engaging with them, integrating them into our project, and collaborating to shape how our services, mainly NOMAD, functions and looks like. All this is done by a team of around 100 people, 60 principal investigators who are embedded in their communities all over Germany. Basically, they provide the guidance of the community needs, and they act as ambassadors for the project within their communities. But more importantly are the co-workers, the core developers, the domain experts who are centrally located here in this building in Berlin. And this kind of set us apart from other traditional scientific consortia, that we are all located in one geographical location, and this kind of gives us the feeling that we are operating a startup software project, which keeps us motivated all the time. So what FAIRmat does, we are developing the solutions for research data management. And this all can be put under the umbrella of the NOMAD ecosystem. Basically, NOMAD, NOMAD Oasis, and NOMAD CAMELS. I will briefly introduce them. So NOMAD is a web-based software. Means that you can access it through your favorite internet browser. And it's for to apply practices of research data management in your scientific process and experiments. And if you want to describe NOMAD in a short statement, it's simply that you share data, not files. And this is also what sets NOMAD apart from other traditional data repositories. So it's not just a place where you have your files to be downloaded by others, but it basically parses and converts your files into a structured manner that can be visualized online, use it for AI models and machine learning and so on through the structuring process. And once the data gets structured in NOMAD, other users could explore them and use them using the graphical user interface or programmatically. And these numbers here, they're from last week. And just to show you the amount of the data that we have in NOMAD right now, so we're close to 17 million uploaded data entries. And we have registered users of more than 4,000 people all over the world. And this registration is required only if you want to upload the data and apply our analysis online. But if people are exploring the data, then I think we have around 13 million visitors per month close to. OK. NOMAD Oasis is an instance of NOMAD that was developed to satisfy the local needs of research groups or universities. And it basically has all the functions of NOMAD, but it can be customized and adapted with specific parsers, with specific ELN schemas, and so on. And it basically allows the user to use their own resources, so their own servers. So the data is stored at your lab, and under your control, you control how to share the stuff and who to give access to. And at the moment, we have more than 60 registered NOMAD Oasis installations distributed all over the world. We have a couple in the US, few in the UK, many in Germany, and also we have in Asia, in the Middle East, we have one Oasis installed at the moment. NOMAD CAMELS is a measurement control software. Basically, it allows you to connect your complex homemade experimental setup formed from several source meter units, sensors, and then you can program them to run your measurement protocols and produce fair, compliant data. And right now, NOMAD CAMELS support more than 200 instruments. So simply by plugging them in and using the graphical user interface, it gets to acknowledge and know these instruments, and you can define the measurements on them. Also, like in case of distributed instrument systems, like in synchrotrons, for example, NOMAD CAMELS supports the connectivity to these instruments using the Apex protocol. So all these solutions work together to form what we call the FAIRmat federated data infrastructure. So we have the nodes here of several NOMAD Oases around the world. They are doing their stuff. They're storing the research data of the groups in a structured manner, some of which might use NOMAD CAMELS to run their measurements, which also automatically sends the data to the NOMAD Oasis. And when the scientists or the Oasis owners decide to send part of the data or all of the data to NOMAD, then it becomes available for the public. Then NOMAD, or the federated data infrastructure, would act as a window or a portal for the scientists all over the world to view the structured data from material science, analyze them, visualize them, and apply machine learning models on them for materials discovery. So let me take you shortly to the main functionalities of NOMAD. And the first thing basically is data exploration. You can query the infrastructure by applying filters and search criteria, either by elements, materials, or the scientific method. And this is a screenshot from the web-based NOMAD. And what it shows here that you can select the elements using an interactive periodic table to filter the entries that are available. And you can see, like, then it shows the list of the entries, and you can go to the next step of accessing these entries and exploring the key metadata and visualizing an overview. So once you click an entry, basically what you see is the basic metadata, such as the name of the method, the author name, and the related publications. But also you get an overview page showing you the key input and output data or quantities of this data entry. As in the example shown here, you can see like the LUTs parameters, the symmetry, but also like the output electronic structure and density of states. And you can explore the entries further by browsing the detailed and the hierarchical structure of the data. So moving from the overview page to the data page here, what you can see is the various subsections that are defined for this type of the data. And going to the specific subsections, you get to see the quantities. And then clicking on the quantity, you see the values associated with this quantity. And basically, all this structuring is happening automatically in NOMAD. What the user had to do is just to drop their files into NOMAD, as I show in the fourth functionality, which is uploading your research data, sharing them with colleagues and collaborators, as well publishing data sets with DOI. And I'm showing an example here of a computation on a silicon material. So basically, you have your input and output files. You just compress them in a .zip or the tar folder, and then you drop them into NOMAD. What happens at the moment is NOMAD tries to associate this file to a specific parser that reads the file and associated to a specific structure, data schema, that then populates the archive. And basically, it lists the entries here, and then you can edit upload numbers, so share with your colleagues, give them a read-write, read writes only, or a read-write writes. You can as well edit the whole metadata, add additional metadata that are not extracted from the file, and publish them either directly or with an embargo period. And as I showed before, you can access your entries in a similar manner as I showed in the earlier slides. And then you have the overview page, interact with the different outputs of these files, and also browse into the subsections, the quantities, and also NOMAD offers this feature of showing the workflow of the scientific processes in a very visualized and interactive way. All what I've shown you here was possible because NOMAD adopts a structured approach to store the data. So any data that comes into NOMAD, either through uploading files where it gets parsed or through a schema-based electronic lab notebooks, will be stored in this hierarchical structure based on well-defined data schema. And we call this data schema in NOMAD as the NOMAD meta info, and it's being extended continuously by our developers. But not just that, we also collaborate with other institutes and other formats. So for example, the Nexus format is continuously being added to our schema to support different base classes available there, as well as collaboration with the NFDI for CAT, where the VOC for CAT taxonomy is also being added for the catalysis field. Now, once you have all your data in this structured manner, it becomes easy to extract this data by machines using APIs. For a specific example, like the Optimade, which is made specifically for material science data repositories. An additional feature of NOMAD is this NOMAD domain-specific faceted search dashboards. It basically allows for a customized dashboard for domain-specific to look at specific fields of the data that are available in NOMAD. And at the moment, and this is from the test Oasis, you can see a lot of such faceted searches available. I think one among the first or the most known one is the Solar Cell app, and I'll just quickly show you how it functions. So it has around 40,000 entries, so 40,000 solar cell devices. And if you open the dashboard, you can start by filtering for the active material, for example, in the periodic table. So let's say we want a solar cell that has the 10 in its active layer. Afterwards, you would filter based on the electron transport layer in this solar cell stack. So you could select C60, and you can see the automatic update of the available entries and the views of this data. And then let's say you would want to change the legend of this figure by showing it categorized based on the whole transport layers, and this can be easily done on the dashboard here. And that's how you narrow down your search to specific entries that match your search criteria. So you have done your literature review without going through hundreds of papers. Then you look at the entries, you can open them and decide how to present them or how to reproduce them. I've mentioned NOMAD Oasis and NOMAD already, but usually we refer to them as the two flavors of NOMAD. And I would like to specifically highlight the key features of NOMAD Oasis as a tool that helps you go through the research data lifecycle process and also the customization features that are available. And if you have a NOMAD Oasis in your lab for your research group, then this basically covers most of the research data lifecycle. So using it as an ELN, you can see you have this rich text field where you can add text, add pictures, and also associate and attach your data files within your ELN and visualize them directly. NOMAD Oasis would support automated data extraction. So in this same ELN, if you just upload your external quantum efficiency file, it gets extracted automatically. You can see, so drag and drop, and the numbers gets populated automatically by NOMAD. You can visualize, you can change the units, and so on. NOMAD Oasis would support also large data files, such as multidimensional photoemission spectroscopy, where you can visualize such files and scan through the inverse case space to see the different cross-section of the photoemission. We also offer the North tools, which allows you to analyze your data right in the place where your data is. So within NOMAD, you can access different analysis tools. Mainly, you can use Jupyter Notebook, but this is also, you can add any other software that you like image processing software. Also, we heard from the project meeting yesterday a couple of examples, like people installing Igor into their NOMAD or Casa XPS, where the analysis is run directly on the platform, and the results of the analysis are then stored directly also in your NOMAD Oasis. This is basically a list of the built-in North tools available in NOMAD. Also, you could build your own search apps that are similar to the Solar Cell app that I showed you, but for your specific data. No matter what the data type you have, you can design your faceted searches accordingly. And I've mentioned already the, I've mentioned the sharing and controlling the access rights into your data, as well using data there as API. Now, we're using the API. So now with the NOMAD Oasis, the key feature is about customization. And this is possible by what we have created, a NOMAD plugin mechanism. And you could think of this plugins as small program projects that you develop to match your specific needs, and then attach them to your core NOMAD installation to add increased functionalities. And what this approach allows you basically, like these key advantages here, so you can have a modular installation of NOMAD Oasis. So if you don't want to use NOMAD for computational data, then you decide only to install the plugins for the experimental data. Also, it allows customizability, meaning that if you have a specific type of data or a specific type of structure for the data, then you create specific plugins for your own data and plug it into your NOMAD Oasis. This also allows you to quickly update your software when a new release is added. Also, provides a collaboration environment where I can use your plugin and you can use my plugin, and then we have a plugin ecosystem that covers the different research methods. And what you can do with the NOMAD plugins at the moment is you can create a plugin for schema packages, basically defining a structure for your data. You can have plugins for parsers, and this basically to read the data and put them into the structured framework that you have created. You can create apps with the plugins, example uploads, and also normalizers having specific functions that run into your data. Of course, one of the main job of our domain experts in NOMAD is to create such general plugins. And at the moment, we have various plugins to support different scientific data. And for example, we have the NOMAD material processing, which focus on providing schema packages for synthesis methods, as well as the NOMAD measurements, focusing on experimental data, such as parsing XRD files and optoelectronics. And these are mainly developed by people from area A. Maybe you could raise your hand so people would know how to reach you in this session later today to chat to you about these plugins. Also, we have a set of plugins that are dedicated for computation and theory, NOMAD simulation, electronic parsers, atomistic parsers. People from Area C, please raise your hands. And please chat to our domain experts about them. Also, we have specific parsers for Nexus tools, such as converting STM data or XPS data to the Nexus format. People from Area B, Rubel, Shandor, and Lucas. And much more. You can go to our FAIRmat GitHub page to see all the available plugins, but also you can read our documentation page on how to install these plugins directly into your NOMAD Oasis installation. But that's not it. You can also write your own NOMAD plugins. And you can either write one plugin that does everything, so it has a schema package, parser, apps, and so on. But also, you can have it as one for each and install them separately. FAIRmat provides you with a template repository that would guide you through writing these plugins. The documentation is available on this QR code. I will share the slides. You can also click these links. And of course, if you need to get support and get in touch with the NOMAD community, the best way we have right now is our Discord server. It's also our internal communication channel. So you would always find someone to either address your question directly or directly direct you to the right person. And my last slide is just outreach stuff. So next year, we're going to be at the DPG SKM spring meeting in Regensburg with an information booth, at the EMRS meeting in Strasbourg, as well as the Psyche conference in Switzerland. And we are planning a lot of tutorials and hackathons and workshops for next year. So make sure you visit our events page regularly to stay up to date. With this, I would like to thank you for your attention, and I'm happy to take any of your questions.